So let's start. What is Docker and what is at Docker's backend? So what it means for a container to be actually Docker compatible, because there are many competitive technologies in the container world. So at Docker's backends, there are namespaces. They serve the purpose that you can separate operating system resources at the kernel level and make them so they don't see each other. That way you can have a Docker process in one namespace, and then you have another Docker process running in another namespace, and those processes don't see each other. So they are practically separated. Then there are C groups. They are quite reminiscent to namespaces in that they basically separate the kernel resources and give you control, special control of those resources. C groups allows you to solve the performance issues that might arise that, for example, some container is too hungry, is consuming too much CPU or too much memory. Well, that can be handled by C groups. C groups can also freeze the process in time, so you can take a snapshot if you are not using a file system that has the snapshotting built in. So next is overlay FS, which is kind of a special file system. It's not file system by itself. It's merely a file system of file systems. It allows you to have a lower layer that in case of Docker is mounted as read-only. And then you have the upper layer, which is mounted read-write. And whenever the file system is asked to locate some file or directory, it first checks whether it's in the upper layer, which is the read-write layer. So it basically checks whether the user made any changes. And if the file is not found in the upper layer, it is searched from the lower layer. So one important thing to note is that the bottom layer is read-only. So the bottom layer is usually your base image, and you cannot change it. So what is the front end? That's the thing that people actually send the commands to and that they work with. So the front end is split into two parts. One part is Docker daemon that runs as a root and it's just the service that starts the containers on behalf of Docker CLI, which is a command line interface that basically allows you to do anything that you can do also with the REST API. So these two a little overlap in that the CLI can do anything the REST API can do. There are little discrepancies, but I don't think they are important. So whenever you write a Docker command, that command is parsed and is sent to the Docker daemon through the REST API. The Docker daemon interprets the data that it got and sets up the namespaces, C groups, and the file system, and basically hands the client the process. Then it depends whether the process is a standard daemon or whether you want the process to be interactive. If you want the process to be interactive, you have to do special precautions. For example, you need a TTI in the container. You need to forward the signals that the process is receiving. But, well, you need to forward the processes anyway because the demonized process needs to handle them too. But well, you need you need to handle just a much smaller part. So, what is a Docker image? Well, Docker image is like the basic block that is used in Docker to build applications from. Docker image is basically a snapshot of a file system. If you try to save one of your Docker images that you got on your computer into a file, you may be surprised that it's a regular tar archive. And that's pretty much it. The Docker image also contains necessary metadata for spawning the containers from that image. There is actually undergoing a work on the version 2 of the image format, because so far we have a version 1 image of the image format that is not very well suited for large-scale deployments, and it's not just deterministic. The new format is distributed in the manifest that is just a signed JSON, and this manifest also contains the name of the image and the tag at the given point in time, because the tag is rather undeterministic thing in the world of Docker, because you can tag one image by a certain tag, and then later on in time you decide that you want to have a different image by the same tag. So you can retag them, but the users, the consumers of your images do not know about it, so they cannot basically rely on the tags. You need a full-blown image ID or digest, it's called in the version 2 image format. And the digest is SHA-9256, and it's computed from the entire manifest. So you actually digest also the tag and also the name. So this way we can fix actually or pinpoint the given tag to the given name and at the given time. Because if someone else comes then and changes one of those layers, they are going to end up with a different hash. So that is how you can differentiate between version 1 and version 2 images. One thing that you probably notice if you try to Dockerize some applications is that the images are read-only. To actually make any change to the file system, you have to commit that change to a disk, and when you do that, you end up with a new image ID. So this way we can achieve consistency. And yes, Docker files are the recipes for images. Actually, the structure of a Docker file I'll have outlined in next slide after the container. So let's first discuss what is actually a container. Oh, well, like I said, the containers, they are like the images, but at runtime. You basically have the copy of the file system, but you can actually act upon it. You can change some files, install new packages, do whatever you want. But whenever you exit that container, all your changes are lost. You need to save them. The containers can be paused and resumed. That is thanks to the C groups that allow you to basically freeze the process in time. So this is very important if you want to migrate one container to another host. You can just freeze the process, take a snapshot, and copy the memory to someplace else. The containers are identified also by some form of ID. It's also a hash, but it's mostly random. What is more important is that you can identify the containers by their name. If you don't name a container, Docker is gonna choose a name for you. I think that if you have ever seen the names that Docker assigns to containers, it's a lot of fun, because it's basically famous people in some situations. It's like Angry Torvald, or Happy Lumiere, or something like that. Well, the container also defines what services are running inside the container. Not strictly what services, but you have to strictly define the ports, the network ports, at which the services are going to listen. And if you need data persistence, for example, you want to containerize MySQL or some other database system, well, then it makes sense for the data to be actually stored and persistent, regardless whether you save the image or not. So that's what for are bind volumes, that you can bind a directory from your host to the container, and whenever you write a file to that bind mount, it also propagates to your host. So that is a way you can make the containers to let the data out of the container. But it has to be well defined. It is always like whitelist approach. The container will not be writing to your disk on your host unless you specified it. Yeah. So Docker files. What is a Docker file? It's a declarative way to specify what should be in the image. Declarative means that when you open up a Docker file, you are going to realize that it is not a JSON, it is not YAML, it's its own file format with special keywords. Those keywords you can see here on the second line. So in short, from defines the base image from which this image should be based on. It's actually, you can either specify the image by name or name and tag, or you can also specify the full image ID. Then comes the maintainer clause. It's just you can write there your name and your email, and whenever someone is using your base image and needs to contact you, he can look up the information in there, just drop you a note. Run. That is basically the workhorse of the Docker file. Run is very similar to, well, it's basically a command that you would type into a bash prompt and hit enter. It would do something, and the result of running that command is return code. If the return code is success, Docker parses another instruction. So it is important that the command that you give to run, the command has to succeed. If it doesn't succeed, the building of your images is going to fail. Next we see expose, which give us an option to specify which ports you want to have in that container open, but it's basically a formal specification in that the container does not need to be listening there. And by mentioning the port in the expose clause, we basically say that if you run this image, you should also open up the port, because if you mention the port in the Docker file, it doesn't mean that when you run the container that port will be open. you still need to explicitly mention that you want to like forward some port from the host to the container. There are switches in the Docker run command that I will show you shortly. So volume, that's almost the same idea, but for the bind volumes. So you can actually have a persistent storage for the container. CMD and entry point are mostly the same in that they define what happens when you don't specify any command to the container. It is like the basic action that the container should do when it's executed, like docker run some image name. Then one of these is going to take place. I said that they are not the same because, for example, the entry point is executed every time. Even if you specify another command, then the entry point is going to get executed too. But the CMD, if you have a CMD directive in the Dockerfile and then specify a Docker run command with the specific command, it's gonna overwrite that is already presenting in the Dockerfile. Work there. That's a tricky one, actually. Like I said, that the run works basically the same way as if you typed the command into a bash prompt and hit enter. What happens when you change the directory? Well, when you change the directory in one of the run commands, it's not gonna work because you basically change the directory in that instance of the shell in which the command was running. But each run command ran in its own shell. So you need to specify the work there in its own directive. Then we have a user directive. That directive basically switches to another user because when you start in a Docker container, you are running as root, which is kind of problematic because you don't want anything running as root in your computer. And if something is running as root, you want to enforce the isolation. But in this case, I guess that in the version 1.6 in Docker, we will finally see the support for user namespaces, which when I talked about the namespaces, there are actually 4 namespaces currently used in the Docker. And in the next version, we will see also the addition of the user namespace. This user namespace is specific in that it allows you to map the user that is used within the container to some different user outside on your host. So this way we can have a root in container and map that in root container to some unprivileged user on the host system. So if some attacker managed to break out of the container, he can do anything to the system because he basically has access of that unprivileged user to which that ID is mapped. So that is a huge win for security in containers. So 1.6, yeah. After executing each instruction, the contents of the file system are snapshotted in a new layer. That is also, like I mentioned, why you can't cd in the run instruction and expect that this information propagates to another run statement that may be right just below. All right. Here I prepared a really minimal Dockerfile. That is a total minimum that you need to get to actually build a Docker image and have it running. You need to define from which image you want to base the image from, and then you just defined what is going to execute when the container gets spawned. In this case, it's just hello Docker meetup, but if you want to see more complex examples, I have prepared some. What? Oh. Is that readable? I didn't touch it. Well, my touchpad is going crazy. Wow. Does anyone have mouse in there? It's jumping all around. Oh. White? Yeah. I would like to, but the touchpad is really all against me. No, this is unreal. No, tam mě ten touchpad zlobí taky. Chápeš, já nejsem schopný. Jo. This is... Well, it took a lot of trying, but finally. All right, let's see what we have in there. All right, so that is the minimum Dockerfile I just showed you, and I'm going to build an image from it. So I issue a command, docker build. Now, if I want to specify the name of the image right now, I can do it with the T switch. So I can name it like, for example, hello, and with the tag, meet up. Oh. And whoa, successfully built. All right, so let's try to execute a container. Be right there. Just to show you the Dockerfile. So, like I said, we begin with the from image and then go on to the CMD. Now, I can add another command to be run during the build. For example, I can echo some value to some file, be it again, hello, nope. now I'm gonna name the image hello2. Well, what happened is that I created the image that prints hello to a file f. Because we didn't specify any work there before, the file is going to end up in the file system root. And now to take a look at the image, what's in there, we can actually execute the container in an interactive mode. Hello2, and I'm gonna override the first command that gets executed when the container starts. Oh. Nope. All right. So this is a shell prompt to the image. And this is our file that we created in the Dockerfile. And oh. All right. There is hello. One aspect that I wanted to talk about is the read-only property of the images. Because if I go on and remove that file, I can do it. The system does not complain, and the file is not already there. So what I do is that I now exit the prompt, and if I get to the container again, well, the file's back in there. To actually make the change propagate and make it like without the F file, we will need to, all right, I'll start the container again. Now I will remove the file, and then in another window, I'm going to issue a command docker commit. That's a bunch of containers. So let's see what is the one that is currently running. Oh, it's not much readable, but we can see that this is the image ID of the container. Right next to it, we see the name of the image from which it was started, then the command that is executed, then some timing information, and set Albertini is the name of the container. So if I'm now, all right. I removed the file, so I'm now gonna diff set Albertini, and it tells me the D on the beginning of the line means that the file was deleted, and it is telling us that the file by the name F from the root directory was deleted. If we want to save the container in this state, we can issue a commit, set Albertini, and we get back an image ID of the new image that is already without the F file. So if mouse is gonna listen, yeah. I'm gonna copy. And if I now start a new container from that image, Docker run. Fuck. What is this? All right, the trackpad is really playing games with me. No. I wanted to copy. Oh no. This is almost painful. Ow! All right. That's really interesting. Okay, so what happened in here that I started the container and it basically executed and quit it right away. So what I need is, oh. So I just need to add like this and tell it to execute bash. Bin bash. We got a prompt. Ouch. And the file called f is not there, so the commit has worked. But now, since we got back this long image ID that we just don't want to use, all right, time's up. So,
something to add or just to finish it?
So I was going to tell that you can actually give a name to that long number through Docker tag, but I guess that could be asked. So. All right, I've gave that image a name AAA, and now I can just issue run. And yeah, and I'm in the same container. So do you have any questions regarding, yes?
I have only one question. If I have Docker containers running and I need to restart the host, all containers are paused and running again after restart the host?
No.
No.
Docker doesn't actually care about what the host do. You need to have some layer that does this for you. You can, for example, use the C group feature that will basically freeze the processes in time. You can snapshot them to disk and then load them from that snapshot, or you can migrate them to another host.
And Docker not provide.
No,
I have
Docker
to use
does not
some
provide
tools.
that.
Okay.
Excuse me. Actually, I think that you have the possibility to start a container with some switch for restarting it on the machine restart. It's what you mean, or not?
Yes. If I running some web server and know it's at cloud and someone need buy upgrade shell or something that I need to restart the host machine. I need to continue with the Docker, not booting again or image from scratch. That is possible to use C groups and snapshots.
Yeah.
Okay.
Exactly like that.
Actually, there's a switch which allows you to say to Docker, to the daemon, to restart your container on the restart of the daemon or on the restart of the machine.
What about live migration? Is there a support yet or not yet?
No. There are only experimental features utilizing the groundwork that was done by OpenVZ. It's called, I think, CRIU, checkpoint restore in user space. It's actually rather interesting and rather crazy because it does all its work in the user space and not in the kernel. But I guess that it's not officially supported, but it can be used. But I wouldn't try it in production.